Sir, I have another question. Can you please enlighten us about the technological requirement of limestone? Limestone का technological requirement क्या है?
Sure. For use in cement making, the most important technical requirements from limestone is its proper dissociation to release reactive lime in the kiln system. In the process of raw material selection, one has to consider effect of two major factors of limestone on its calcination behavior. That is, number one is associated minerals and impurities, and number two is physico-textural features, including grain size of calcite. First, I'll discuss about associated minerals and impurities. The effect of the associated minerals and impurities like silica, alumina, and iron oxide is basically to lower the decomposition temperature of calcite. It has also been observed that the lime crystal obtained from the dissociation of dolomite are 1.5 to 2 times smaller than those obtained from calcite. As a result, the reaction surface is larger when lime crystals are available from dolomite, resulting in faster reaction. It is known that MgO in limestone can be present in various forms like dolomite, ankerite, magnesite, magnesium silicate, brucite, etc. The growth of periclase in clinker is obviously related to the temperature at which different magnesium minerals releases magnesia on decomposition. Lower this temperature, greater the chances of crystal. The presence of coarse grains of quartz or siliceous veins is undesirable, as it may affect the grindability and reactivity of the limestone. Now let us see the decomposition temperature of magnesium minerals. Now dolomite chemical composition we know is double salt of calcium carbonate and magnesium carbonate, and it decomposes at 700 to 750 degrees centigrade. Ankerite is salt of calcium, magnesium, and iron carbonate, and it decomposes at 700 degrees centigrade. Then you have magnesite. Magnesite is magnesium carbonate. It decomposes at 660 degrees centigrade. Then you have magnesium silicate, that is MgSiO3. It decomposes at 580 degrees centigrade. Then you have brucite, that is magnesium hydroxide. It decomposes at between 375 and 490. Now let us come to physico-textural features. The physical properties of limestone show wide variation, apparently related to the prior history of rock formation and the resultant minerals and textural features. The color of limestone reflects the level and nature of associated minerals and impurities. High purity calcite limestone is white in color, and other shades in the less pure varieties are essentially caused by carbonaceous and ferruginous materials. Porosity of limestone varies from almost 0% to 30%, while the upper values for chalk and marls often goes up to 40% and 50% respectively. For predominantly occurring compact limestone, it is in the range of 2 to 5%. Similarly, dolomite normally show relatively low porosity level, that is 1% to 10%. The water absorption in limestone follows the pattern of pores and the level of porosity. While it may be negligible in dense varieties, it may go up to 20% in porous chalky varieties. The Mohs hardness of most limestone lie in range 2 to 4. The apparent density of limestone on drying at 110 degrees centigrade ranges from 1.5 to 2.6 gram per centimeter cube. The crushability of limestone is highly variable due to intrinsic variability in grain size, porosity, nature of cementing material, degree of weathering, natural moisture content of different limestone, as well as within the limestones of the same deposits. Now let us see crushability of some of the commonly encountered limestone. You have argillaceous limestone. Compressive strength varies from 830 to 1320 kg per centimeter square. Then you have fine grained limestone. Compressive strength 1000 to 1700 kg per centimeter square. Then you have clastic limestone. Compressive strength varies from 1300 to 1700 kg per centimeter square. And finally, siliceous limestone. Compressive strength varies from 2000 to 2200 kg per centimeter square. The grindability of limestone is also variable. The bond index for commonly occurring compact limestone lies in the range of 4 to 13 kWh per short ton. The reactivity of limestone is dependent on the crystal size of calcite and other associated minerals, and more particularly water.
आशा करते हैं दोस्तों आज आपको अच्छी खासी जानकारी हासिल हुई होगी। अगर हमारा वीडियो आपको पसंद आया हो लाइक और शेयर जरूर कीजिएगा। अगर हमारे YouTube चैनल पर नए हैं सब्सक्राइब करना ना भूलें, बेल आइकन को जरूर हिट कीजिएगा, जिससे आपको लेटेस्ट अपडेट नोटिफिकेशन मिलता रहेगा, हमारा मोटिवेशन बढ़ता रहेगा। और दोस्त मैं एक चीज़ और आपको बताना चाह रहा हूँ कि आने वाले सीरीज़ में आपको सीमेंट से रिलेटेड जितनी भी जानकारी आनी है केमिस्ट्री से रिलेटेड वो सारी 1 बाय 1 आती रहेंगी। आप बने रहिए और इंतज़ार करते रहिए, बने रहिए, नोट उसका बनाइए और सीमेंट केमिस्ट्री की पूरी जानकारी आपको इस चैनल के द्वारा प्राप्त हो जाएगा। वीडियो देखने के लिए बहुत बहुत धन्यवाद।